Now we define definite integral as the limit of sum. This concept we can arrive as follows. We did not face any difficulty in the finding of area, definite integral, under a straight line and between two vertical lines. The difficulty thus arises when the graph is not a straight line. To overcome this, we have the following theorem. That is, if fx is continuous in closed interval ab, then a to b fx dx is equal to limit h going to 0 h times summation of sigma r going from 1 to n f of a plus r h, or limit h tends to 0 h times sigma r going from 0 to n minus 1 f of a plus r h, where h is equal to b minus a upon n. Explanation for the above is as follows. Let y equal to fx be a continuous function in closed interval ab. Let a and b be the points on x-axis corresponding to x equal to a and x equal to b. Let a dash and b dash are the points on the curve y equal to fx, where x is equal to a and x equal to b. Then a dash and b dash are the points a comma fa, that is y ordinate at a because y is equal to fx, and b fb respectively. Now we divide ab, which is equal to b minus a, into n equal parts, so that the length of each part is equal to h equal to b minus a upon n. If a1, a2, a3 dash 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 an minus 1, an, which is equal to b, be the points of division, their x coordinates are a plus h, a plus 2h, a plus 3h, so on, a plus n minus 1 into h, and a plus nh, which is equal to b. Their corresponding ordinates on the graph of y equal to fx are f of a plus h, f of a plus 2h, f of a plus 3h, f of a plus n minus 1 times h, and f of a plus nh. We construct the rectangles on each parts a1, a1, a2, a2, a3, and so on, with its height on the right ordinate. If Sn denote the sum of the areas of these rectangles, as we see from the graph, then Sn becomes equal to h times f of a plus h, h times f of a plus 2h, h times f of a plus 3h, plus so on, plus f of a plus nh. Pulling out h common, which is equal to h times summation r going from 1 to n f of a plus rh. Now if we replace n by 2n, the sum of the areas of the rectangles gets closer to the area under the curve, which we are required to find. Clearly thus, if n tends to infinity, the limiting value of Sn gives the accurate value of a to b fx dx. Thus, a to b fx dx, that is what we have observed, is equal to limit n tends to infinity of Sn, that is equal to limit n tends to infinity h times summation r going from 1 to n f of a plus rh, where h is equal to b minus a upon n. This is what we had to find out. Now note 1r, if we take the height of each rectangle as the ordinate of the left hand corner, then proceeding in the same manner, we get a to b fx dx is equal to limit n tends to infinity of Sn, which is equal to limit n tends to infinity h times summation r going from 0 to n minus 1 f of a plus rh, where h is equal to b minus a upon n. Second, the symbol integration represents integration